Hey guys, Mr. Betts here. In the last topic, we talked about what a differential equation is and how we might, for different situations, set up differential equations that model some situation. Now I want to talk about how we can verify a solution to a differential equation. So let's talk about a couple of definitions here first, real quick. So first of all, this is an old one, but a differential equation, remember, is just any equation with a derivative in it. And the new definition here is what a solution to a differential equation is. And so solution is essentially going to be a function that satisfies the differential equation when f and its derivatives are substituted into the equation. So a differential equation has a derivative in it. A solution to a differential equation will not have a derivative in it, but when we plug that function into the differential equation along with any derivatives involved in the differential equation, then that equation is going to be true. So this is really a topic where it's just a matter of looking at examples to see how we're going to do it. So we want to verify that this equation right here, which is a function, is a solution to this differential equation right here. And again, it's a differential equation because it has that derivative in it. So what we're going to do is we're going to take the function itself and plug this in for y. And we're going to take the derivative of the function to plug in for dy dx. All right, so let's kind of start from the beginning here. I'm going to take this function. I'm going to take the derivative. So dy dx is equal to, we've got chain rule on the first term here, so it's going to be negative 4e to the negative 4x, and then derivative of 2x is 2. So that expression I'm going to plug in here for dy dx. The function itself, I'm going to plug in here for y, and I'm just going to rewrite that whole expression. So instead of dy dx, we've got negative 4e to the negative 4x plus 2 plus 4 quantity e to the negative 4x plus 2x plus 3 minus 8x equals 14. And since we're verifying this, we don't know for sure that these are equal yet. What we're really trying to do is check to see if they are equal. So I'll usually write a question mark above the equal sign right now because we don't know that they're equal until we do some simplifying. So I think it's kind of obvious. The first thing we're going to do here is distribute. So everything else will stay the same. 4e to the negative 4x plus 2 plus 4e to the negative 4x plus 8x plus 12 minus 8x, and I'm not even going to worry about the 14 right now. We know the right side of this equation is 14. We'll just leave that alone. We won't touch that. And we're going to have some simplifying to do here. So the negative 4e to the negative 4x and the positive 4e to the negative 4x, those cancel each other out. The plus 8x and the minus 8x cancel each other out. So all that's left is the 2 plus 12, which is 14, which confirms then that this equation is true. So we have 14 equals 14, and we have confirmed that this function is a solution to this differential equation. One thing I want to point out is a lot of differential equations are going to use the Leibniz notation dy dx. A lot of them will also use prime notation for derivatives, so you'll see a differential equation that looks like this, y prime or y double prime. So just understand that means the same thing as the dy dx.